Piston in a car. Introduction to simple harmonic motion. An important type of motion is periodic motion. Some examples of periodic motion are circular motion and oscillatory motion. Oscillatory or harmonic motion is different from the earlier types of motion as it is periodic or repetitive and the acceleration is not constant. Examples of harmonic motion are the oscillation of simple pendulum, the vibration of atoms, the movement of spring mass system, the motion of a piston in a car's engine, the vibration of molecules when sound travels in air. In this lesson, you will be able to define simple harmonic motion, define amplitude, period, frequency and angular frequency of a simple harmonic motion, learn to draw the graph of x, v and a against time t, show that the expression x equals x naught sine omega t is a solution of the equation a equals negative omega square x, and derive the expression for velocity v equals plus or minus omega times square root of x naught square minus x square. A body is said to be in simple harmonic motion if its acceleration a is directly proportional to its displacement x from a fixed point. The acceleration is always directed towards this fixed point, which is its equilibrium position. One end of a helical spring is fixed and a mass is attached to the other end. The mass is placed on a smooth horizontal surface. Click the play button to displace the mass from the equilibrium position. When the mass is released, the restoring force in the stretched spring causes the mass to move back to the equilibrium position. The spring is then compressed. The restoring force in the compressed spring pushes the mass back, and the motion is repeated in a periodic manner. The restoring force on the mass is always directed towards the mean position. Click the play button and observe a table being tabulated with the values of acceleration a and displacement x. A graph of acceleration a against displacement x is also plotted simultaneously. The variation of the force F on the mass with its displacement x from the equilibrium position is as shown in the table and the graph. During the simple harmonic motion, the mass is displaced to a maximum distance of 8 centimeters from the equilibrium position. This maximum distance is known as the amplitude of simple harmonic motion. What is meant by a complete oscillation of a simple harmonic motion? Click Answer. An example of a complete oscillation is a complete to and fro motion from point A to B and back to point A. Click on the mass as it passes any position and click again on the same position after it completes one oscillation. Time taken to complete one oscillation is called the period of the simple harmonic motion. Its unit is second. Click on the mass as it passes any position and observe the period of oscillation shown in the timer. Click on the mass as it passes another position and compare the period of oscillation. Thus, we can conclude that the period of a simple harmonic motion is constant. The frequency of a simple harmonic motion is the number of complete oscillations per second. Hence, frequency f equals 1 over period. Its unit is Hertz. The angular frequency of a simple harmonic motion omega equals 2 times pi times f, where f is the frequency. Its unit is per second. Summary. A body is said to be in simple harmonic motion if its acceleration is directly proportional to its displacement from a fixed point, known as the equilibrium position, and is always directed towards that fixed point. The amplitude of a simple harmonic motion is the maximum distance from the equilibrium position. The period t is the time taken for a complete oscillation. The frequency f is the number of complete oscillations per second. Angular frequency omega equals 2 times pi times f.